Hello everyone, and welcome to the first skill review video that I have for pre-calculus. These videos are designed to go through and quickly show you how to do different skills that you've learned all the way up through Algebra 2. So for this particular video, our skill objectives are, number one, solve linear equations, and number two, solve application problems. The conceptual objective for this one is to understand the mathematical modeling process. The first thing we want to look at is just in general how to solve linear equations. These can range in difficulty from a standard two-step problem that you saw a lot in Algebra 2, like 2x plus 7 equals 14, or they can be a little bit more complicated like this one that you see here. Now in this problem right here, we have a number of different things that are going to cause issues. Number one, just all the different groupings that are taking place. You got the brackets here, parentheses in there, and also a negative outside here. When it's on a coefficient like this, generally not as much of a problem, but in this case here, we do generally have more of an issue. The standard thing that I tell students to do is start working inside out. So in terms of working on this left-hand side, the first thing I'm going to do is deal with this minus 3. So I distribute the negative 3, and so I have 25 minus the quantity 2 plus 5y minus 3y minus 6 equals, and then what I did here is distribute that negative 3, and then the other thing you have to do, you have to remember to distribute that negative 1. So when I distribute the negative 3, I get negative 6y plus 15, and when I distribute that negative sign there, I get minus 2y plus 2. Notice how that did change it. Probably the main mistake that I see students make is when they deal with this negative sign, forgetting to take it to everything inside the parentheses. So when I combine the like terms, I get 25 minus the quantity 2y minus 4 equals negative 8y plus 17. And then distributing that negative sign, I get 25 minus 2y plus 4 equals negative 8y plus 17. Combining like terms here. Now at this point, what I need to do is I need to get all the y's on one side and everything without a y on the other. So I added 8y to both sides to get 29 plus 6y equals 17. Subtracting 29, I get 6y equals negative 12. And dividing by 6, I get y equals negative 2. Take a minute and make sure that you're comfortable with everything you see in this problem. And when you are, we'll move on to the next one. In this particular problem, what we're looking at is solving linear equations. So in this case, again, we're not going to see any variables in the bottom of the fraction, but we want to solve the linear equations where we have fractions in the problem. So in this case, I have 3x over 5 minus x equals x over 10 minus 5 over 2. The first thing you're going to want to do, one of the most common, best way to work with this is really what everybody would like to do, get rid of the fractions. And you do that by multiplying both sides by a common multiple of the denominators. In this case, the least common multiple is 10. Can you use something bigger? Sure, but the easiest one to work with is going to be a 10. So what I did at this point is by multiplying both sides by 10, I distribute the 10. So that gave me 30x over 5 minus 10x equals 10x over 10 minus 50 over 2. Now, would you have to write all this out? No, you don't. If you can go through and simplify it as you go, please do so. When you reduce that fraction, you get 6x minus 10x equals x minus 25. Combining the like terms, I get negative 4x equals x minus 25. And then subtracting an x from both sides, I get negative 5x equals negative 25. And so therefore, x is equal to 5. Again, take a minute, make sure that you're comfortable with everything you see on this problem. And then once you are, press play and move forward. One of the things that students really seem to like the least when working on math problems is story problems. So this is where we want to use what's called the mathematical modeling process. Okay, and this is where we're going to take a real world problem. We want to be able to translate it into math, identify from that, after the translation, identify a mathematical model. That's an equation, and then solving that equation, and then identifying the solution to that real world problem. So the process that you want to go through when you're working on this, the first thing is you want to identify the question. Read that problem over, identify what they are trying to find. Step 2, make notes. This might require reading the problem a second, third, or fourth time, multiple times. But you want to identify the given information, things that you can draw together to form a relationship that you're able to solve. The next thing you want to do is you want to assign a variable to whatever you need to find. Now, this can be a little bit tricky because sometimes you might have multiple things you want to find. In that situation, you want to assign the variable, give the variable x, if you will, to the smallest quantity if you are able to identify that. Step 4, we want to set up an equation. Get some equation we can work with, and then step 5, solve that equation. Now, once we do that, just because we solve the equation does not necessarily mean that our answers are going to be feasible. Our equation is a mathematical model. We are looking at a real world situation. So in some situations, solutions that you get from the mathematical model may not necessarily correspond to what is a possible solution in the real world situation. So in that case, you do want to check your solution, and then you also want to look at that and put that in terms of the problem itself, what you're actually working with. And this is where the units also come into play. To demonstrate the mathematical modeling process, we will look at a couple of different types of problems. The first type of problem is what's called a mixture problem. A student needs 100 milliliters of a solution that has 11% HCl. The storeroom has solutions that are 5% and 15% HCl. How many milliliters of each should be mixed to get 100 milliliters of 11% HCl? So step 1, identify what we're trying to find. In this case, we're trying to find out how much of each solution we need of the 5% and the 15% solutions we need to go through and produce the required amount of 11% HCl. Step 2, we read it again. We notice that we do need 100 milliliters, and we have 11%, 5%, 15% solutions. Now, in this case, we want to go through and assign the variable. Now, we did say let it be the smaller of the two. So you have a choice. We can't necessarily say which one is the least amount here. So what I'm going to do is I'm just going to let x equal the amount of 5% solution. Now you could go through and let x equal the amount of 15% solution. It's not going to make a difference on the problem. And then after that, I'm going to say that since we know we have to have 100 milliliters total, x is the number of milliliters of 5% solution, so the number of milliliters of 15% solution we need is 100 minus x. Now at this point, we want to now set up an equation. Really what we want to do is identify an equation that ties the amount of HCl together, equates it. So what I'm going to have is the 5% would be 0.05 times x. That's the amount of HCl in the 5% solution, plus 0.15 times 100 minus x equals 0.11 times 100. So this now gives me my equation that I need to solve. At this point, I would like you to pause the video and then solve this particular problem. Welcome back. Now at this point, I have now solved that equation. We had, when I distribute the 0.15, I get 0.05x plus 15 minus 0.15x, and then multiply that out, I get 11. And then combining all the like terms, keeping everything with x on one side, everything without an x on the other, I get that negative 0.10x equals negative 4, so x equals 40. So with that, we now know x is 40, and so I know for this particular problem, I need 40 milliliters of the 5% solution, and then it's going to be 60 milliliters of the 15% solution to produce the required amount that I need for that the student needs for this experiment. Another type of problem that we have that works in terms of a linear type of solution is going to be what's called a work problem. In this case, we have Jay and Haley are working for a landscaping company, and it takes Jay 3 hours to complete the largest yard when he works by himself, and 1 hour if Haley works with him. How much time would it take Haley to do the job alone? So the first thing we have to do is go through our process again. Step one, what are we trying to find? We're trying to find how much time it takes Haley to do that job. Step two, identifying notes. Well, we got a couple of things we know here. One, we can see that it takes Jay 3 hours, and if they're working together, it takes 1 hour. So that's what we have here. And so the third thing is we want to assign a variable. In this case, we only have one thing we're trying to find. We're trying to find how long it takes Haley to do the job. So we're going to let H equal the time it takes for Haley to do the job. Now, step four is coming up with an equation. In this situation, what we want to do is identify what portion of the job each will get done in 1 hour. So in this case, I know that when Jay works alone, he does the whole job in 3 hours, so he can do 1/3 of the job in 1 hour. Haley, now Haley in this case is looking at all we know is that it takes her H hours to do the job when working alone. So in 1 hour, she will get 1/H portion of the job done. And then if they work together, we know that when they work together, that they can get the whole job done in an hour. So it would be 1/1. And so in this situation now, we do have a situation where we have fractions. So we want to now solve this one like we did when we solved the other problems. In this case, though, we're going to multiply both sides by 3h. So what I'd like you to do, pause the video right now and do step 5, solve the equation. And then once you're done, come back and we'll talk about the solution on this one. Welcome back. So in this situation, once we had that equation, we said we had 1/3 plus 1/h equals 1/1, or we could just say that equals 1. We knew that we had to go through and multiply by our common denominator, which in this case was 3h. So I have 3h times 1/3 plus 1/h equals 1 times 3h. And so when I distribute the 3h inside, 3h times 1/3 is h. 3h times 1/h is going to be 3 equals 3h. Getting all the h's on one side, I get 3 equals 2h, so h equals 3/2. So that's our solution. Now, in terms of this problem steps, this is all step 5. That work is step 5. So now for step 6, we need to identify how much time it's going to take Haley to do the job. Since h is 3/2, we know that is equal to 1.5. So in this case, it's going to take Haley 1.5 hours to do the job alone. So with that, these are a couple of examples of story problems associated with these linear equations. If you have any questions on them, please go back through, double check my work, double check your work, see if you can clear those up. If not, please be sure to ask them in class. So hope this helps, and we will see you next time in class.